Hi, everybody. Good morning. Hope you're having a great day so far. Welcome to our session today, starring Tyler Mitchell. He's a senior product marketing manager at Couchbase. He's going to go through everything about future-proofing AI data architecture, which I know is something that is on all of our minds these days. I just want to call your attention to a few different things in the docs section that is to the right. There's a survey there. We would really like you to get some feedback from you, to know a little bit more about where you are on your database journey. So if you have some time to fill that out, even after the session, you can do that. We'd really appreciate it. And then in July, we're going to continue on this conversation, slightly different topic, talking about building enterprise AI agents and overcoming data challenges. So, similar topic to what Tyler is going to talk about today, taking it a step further in the enterprise direction. And if you do want a copy of today's presentation, that is in the docs section for you as well. And with that, I am going to let Tyler Mitchell kick it off. Thanks so much for being here, Tyler.
Thanks, Suzanne. Yeah, everyone, before we jumped on the call this morning, we were talking a lot about geography and where people are from. I'd love it if in the Q&A or in the chat there to drop in where you're watching from. It's always fascinating. I'm in Western Canada, in Alberta. So we're up here in farming and ranching and oil and gas country. But
Yep.
with the magic of the internet, here we are talking about
Here I
data
am in
architectures
Silicon.
for AI.
Yeah, here I am in Silicon Valley. So, wishing maybe I was on the farm sometimes. But here we are.
Yeah, so drop a note, let us know. Great. So I already got some Pacific Northwesters here, so we're feeling good. Yeah, so we do a lot of presentations on our product line and how it services specific needs and use cases. And we also talk a lot about modern challenges that our customers specifically deal with. Couchbase, we have a data developer data platform, specifically tooling up for AI, but we've been around for a while, for over a decade, building memory first architectures for your data solutions. But today I just want to kind of take a step back and not so much talk specifically about our products, but to give you the idea of how to picture your AI foundations going forward. Because a lot of times, if you're like me, you hear about a new tool or a new capability or some new LLM or a new chatbot or whatever, and you jump in, you just try it, you go, oh, it works, and you start to look at how you would integrate that into a solution for your company, your business, your customers, etc. But I think it's worth taking just a step back, taking a deep breath, and thinking through what challenges you're going to have to address. Now, of course, I'll touch on a bunch of those in this talk. It won't be too much a brand discussion, but I will talk about how Couchbase pulls it all together in the end, so makes it a little easier for you to get started. But really want you to step back, and I'd love more questions and chat and stuff about how the challenges that you see that you're dealing with in AI. I mean, you could drop that in chat now too, and I'll try to look at it throughout. So this is kind of like in a nutshell how I see things for in the overall landscape of AI today. We've got constantly moving targets. Everybody wants, general AI to start running their business. Everybody wants a chatbot that can do no wrong, and everyone wants, analytics that are, highly sophisticated based on AI models, etc. There's new products, new models, new frameworks every day coming out. And there is, more of a push towards standards, building standards that you could build against. And obviously those are really important going forward. But they're changing and they're new, and there's different players involved, and there's proprietary versus open source, and consortiums of companies working. There's the cloud vendors, and there's independents. It's very liquid, fluid landscape at this point in time. And then if we look at it kind of from a technology standpoint, as you're architecting your solutions, they're just increasingly complex. How do you pull all these different pieces together without experiencing massive data sprawl and limited scalability, both things that you've probably had to address over the last decade or two, where you're really laser focused on making your applications run well. But now we've got way more complexity wrapped around that. You'll hear these same points over and over in this talk because that's really that complexity is really the game changer or potential game breaker for companies out there that are adopting AI. And then poor developer experience, that doesn't get talked about as much as I think it should. That the architecture that you hand over, say, to your development team should make it easier for them, that they don't have to go and learn 10 new technologies. They should learn a couple new technologies. They shouldn't have to, install and test 20 different models to find the best one. They should be able to get to that endpoint sooner and faster with less work. So that's kind of my background, assumptions, and framing for the whole conversation. Now I've got a list of what I call the technical challenges of the last 40 years that we've had to deal with in technology. I mean, some of these, like when we get into models and agents, is a little different, but imagine all of the challenges that you've had to deal with around compute capability. So CPUs and GPUs, the ability to process data and push it through a pipeline fast. Those were problems. Oh, by the way, I'm going to go through these kind of in an yesterday's paradigm or today's paradigm, and then I'm going to talk about them in an AI application paradigm. So that's why there's some blank screen here. We'll fill that in a second. But we've been laser focused on how do you compute data, calculate data as fast as possible, making your applications not slow, aiming towards real time. We'll talk about the customer demand for real-time interaction in a minute. But that's been a laser focus. Storage has always been a problem. Where do we put the data? How much room do we have for data? How do I make sure that the data doesn't get old or get deleted by mistake how do you handle and estimate what your data needs are going to be tomorrow? These have been problems, for decades. And obviously with the cloud revolution, we could say, was the last time all of these were really upset. Okay, so we kind of had data transformation challenges before the cloud. Then we had different data challenges or solutions to a lot of those challenges in the cloud and limitations in the cloud. And now we're talking about AI over here, yet another kind of stop on the railway line of data applications. But storage and compute were obvious ones. Models a little less so, unless you're into like predictive analysis and stuff. We're dealing with models. How do you share models? How do you standardize them? How do you keep them around? I'll dig into the AI ones in a second. And then we just talk about application development, and today it's agents development. But application development and building applications that go from mobile devices to the internet to the cloud, and back to someone else's mobile device. The complexities involved along that route have been there for a long time. And I didn't even mention really like networking and things like that. But those challenges, how do we build apps that are, right to the edge, that are maybe can run offline, can synchronize online? Like those have been solutions that we've built our systems around, and that everyone's kind of had to figure out what their solution is. Data processing, obviously a big one, especially as data became big data, then data processing became even harder. But solutions popped up, solutions have been adopted, somewhat standardized, but still a lot of room there. Now we add in AI and we go, okay, this becomes a little bit more of a challenge. I say times 1,000. I don't know if that's realistic. It's the same technical challenge with your compute infrastructure as it was before, but now you've got a whole bunch of other issues to deal with. So the computational abilities of your historic systems will naturally need to grow alongside the use of any AI tooling. If you go and download, was it LM Studio, LM Studio to try out some models on your computer, on your local PC or in your desktop or laptop. You'll know right away compute becomes important. Even though you're not training a model, you're just using the model, you're going to hit those limitations of memory and CPU or GPU performance immediately. Imagine how adding that capability to your application will make it that much harder for your application to run. It used to be you just pick a database, put it behind your application and go. Now you're putting an AI, an LLM behind your application, for example. You can't just drop it in and go as easily as you would with a data system. So in some cases, you'll actually never even have enough compute power to provide the right cost benefit ratio here. So, when you start talking about training and building in more complex algorithms and workflows, you might not have the resources you need with your current setup. So you're going to have to look at that. You'll need to find ways also to improve that performance by using caching, caching the results of your computations. So saving them so that next time someone asks the same question, you're right there with an answer already without having to go maybe to the LLM again or go to a third-party LLM and incur costs, etc. Same with storage. We're talking, I won't go through all these in super detail, but we're talking about going way beyond operational databases as you've thought of it before. We're dealing with things like vector embeddings, indexing those vectors in your database or in your vector storage, whatever it is. I won't assume our platform in this mix. And you have to have the space for handling all those embeddings. So if you have, a large amount of data that you're going to want to have access to in your AI application, you're going to have it in the database somehow. And then you're going to have embeddings that describe that data and make it searchable through vector search capabilities. So if you don't know some of those terms, look them up and you'll see what I mean. And then there's this whole idea of there will be like processing that's done as well, where the AI has to create new data temporarily or ephemerally. And so you're going to need to maybe balloon and expand your storage capabilities and then retract those later when you don't need all that again. So it's kind of like maybe temp storage. You could think of it as that. These are real challenges you're going to have to manage. Models, how do you choose the right model? How are you storing it and making it available to your application developers? And of course, versioning will become important, and also just serving up LLMs as well as agents, as well as cataloging all of the stuff that you have available becomes a whole logistical nightmare if you don't have the right tools to help make that workflow easier. Agents too, there's a whole data management challenge around agentic AI applications. We talk about let's have a dozen little agents that are doing their very discrete things and then sharing stuff with each other or sharing stuff with kind of some master agent that's running. Well, each of those has their own data management challenges. They have to access a database. They have to access a user. They need to do some kind of analytics. They need to store the results somewhere, stream them somewhere else. Like just the sheer volume of moving parts in this equation is extremely foreboding for a lot of people. And then data processing is just prepping your data and getting it into these systems. And it's not just tabular data; it's text data. It's obviously visual data and music data and things that get embedded and created as text indexing, as vector indexing in your database. It's a wide range of information. So we could end the call there and say, figure out your plan for dealing with all of these, but there's more challenges, and we'll get into some more specific challenges in a minute. Okay, so let's take a breath for a second and step back, and this really isn't about our product, but this is about our customers. And what we hear. We could say users or developers. This is what we hear from users, from developers who are looking forward, like we're trying to do in this call, to think about what's the AI architecture look like going forward. Well, here's what the assumptions already are. Great experiences are built on personalized and real-time interactions. And they have to go from the mobile device, in many cases, all the way back to some data center somewhere. That's a Louis Vuitton mobile catalog product built on Couchbase. We on the left there is an example of the edge examples. We know that modern apps look and behave differently than traditional apps. We have like dynamic data, so people are typing stuff in instead of just choosing stuff from lists, for example. So your applications have to be able to handle more than just static inputs. There's social interactions, and the user experience has to be real time. Like we can't keep people waiting anymore. So that means maybe caching stuff on the device as much as possible, serving that data up from a data center that's as close to the user as possible. And really this AI kind of revolution that's going on is really the opportunity for you to really readdress maybe some of the fundamental architectural challenges that you're dealing with already. So your data developer platform can wholly be reviewed at this point. And it's really the catalyst for change in this area. And developers need to be able to use these things quick. There's other modern requirements, such as a large number of users, a lot of data. You need flexibility. You can't just be, hard coding apps to say, just give me this table of data and everything's fine. It's got to be dynamic. We're talking about, when we mix in AI too, we talk about JSON as the AI's language, built-in language, data format for AI is JSON, and it's used in a lot of the libraries and backends. And Couchbase is built on JSON as a database. And you can query JSON just like you would SQL tables, but you can also extract JSON as a document, for example, in our system. So all of these requirements are here, and kind of behind it all is also the requirement that there's a lower TCO. So not only are there exponentially more systems and tooling involved and challenges that we've just gone over, but the expectations are even higher now too, that we'll be able to do things with less people and with less systems and do it cheaper and faster. So they're very competing interests in many ways. So with all those developmental requirements in mind, once you start down that road of building a plan for your AI architecture, you're instantly hit with this massive complexity and way more options than you will ever need. Used to be, you'd say, I'm a Microsoft shop, I've got my stack, or I'm an open source LAMP developer or whatever. You'd have a stack of technology stack that was already kind of almost prescribed for you, and you knew what outcomes you'd get from it. But now we're talking about all of these different stages of data accessibility, data management, and how do you share it with other people, how you share it with agents that are running in the background. And it's really very, very complex. This screenshot here is from the Hugging Face project, where which is a landing page for everybody who's getting into AI will invariably get some tool or model from here. This is a snapshot of page 1 of their list of models. The two columns on the right here are just model names. They have 1.7 million models in their database here. It's like people upload them and index the models they've created and things like that. And then you go in and grab them. And then there's filters on the left, so you can see all the different kinds of models that are available. But that's page 1 of 100 of 1.7 million models. And then they also have an application directory. So if you want to get started quick with something, you can go and access application directory. Again, this is part of page 1 of 100. They've got thousands of applications in here to help you get started. But good luck. You'll have to maybe use the filter, that row across the top there, to choose what you want to do. Synthesize audio, edit images, make videos, and then see what they've got available. But there's, no one's going to tell you this is the one thing to use for chatbots, because that kind of decision making is up to you. And then this is another screenshot from the Superlinked website. They've got a setup where they enumerate or catalog all of the vector databases, and Couchbase is down there is one of them, and all the capabilities of the vector database. Now, you might not know what all of the columns mean here. Heck, I had to look it up when we were filling this in. But there's a lot more attributes than what's shown here, and you'll have to learn some of those to decide whether you're interested in that database as your vector database backend or not. So if that's not enough complexity to overwhelm you and just throw your hands up and say, save me, here's my money, then we'll keep on going, just to show, again, no matter what architecture you're going to build on, no matter what vendor, cloud provider, online, offline, mobile database support, etc., just keep these in mind and make sure that you're checking these boxes off to address them. The new paradigm of AI and development and management challenges, it brings the traditional bolt together data architecture design isn't really ready for AI. It used to be, for those of you that maybe worked more in open source environments, we'll just simplify it and say, you'd get your web server, you'd get your database, you'd choose 5 or 6 things that worked well together, that had good integrations between them, and you were set, because your user application, hit your web server did a database query, sent data back up the line. And that was really straightforward and simple. And so you could kind of bolt together several modules, but maybe you'd only bolt together 3 or 4. Now we're talking about bolting together like a dozen or more components just to make an AI application really robust enough to perform and deliver the capabilities that people expect. And this extra dimension of AI, because the box to the right here, just triples kind of the complexity even further and makes it harder for your stack to scale. So you're going to need at some level to choose from each one of these traditional applications on the left and bundle them together, and then have them all be able to talk to the same AI ecosystem interfaces, and maybe even each one of those components will have to talk to the AI ecosystem. And we've even simplified the AI ecosystem box here to just being like the cloud service providers, and using like NVIDIA's NIM offering that kind of catalogs and makes available the models for you easily. If you were to change this slide into showing a lot more options, it would be many slides worth of information, like you just saw in those previous screenshots. So even when we simplify it like this, it's still exponentially more challenging to add AI capabilities on top of a disparate stack of stuff. You'll notice Couchbase, we have our logo in all these boxes because we already handle each one of these. So that's why a unified data platform like Couchbase is preferred. But not to dwell on that, but also to dwell on the unstructured data box here. A lot of systems aren't ready to even handle different kinds of unstructured data. So you need one, like a NoSQL database, that's already ready to go with handling more than just tabular information. And I should say, when we talk about AI architecture, we often miss out on the idea of caching and of transactional data requirements. They're kind of like an afterthought, but you still need to have access to what your single kind of source of truth is for your user base and for your application. It's not just all about vector data. It's about how you make vector data useful against your other corporate assets. It's not about just finding vector matches. It's also about how do you find vector matches that relate back to the information that you work with and produce and that your customers create every day. So if you don't have that capability and you don't have the capability to analyze that information or those relationships, or you don't have the ability to send that back to a mobile platform so that people in the field can access it, then you're really not talking about building an AI architecture. You're just building like a one-off app that uses vector data. How are you going to incorporate all of these components and couple it with AI and make it a performant app with all of those demands that we were just looking at earlier? So I can back up a little bit and look at the reason that things have changed is old paradigm used to be the single user would access a single application screen. They'd choose from some static inputs. System would go to a database, single database, probably on one machine, and get the information, bring it back, and send it back to the user, whether it's like a web or a mobile app, for example. But most inputs from the users in this scenario are specifically rigid, and the data has a structured nature to it already because it's in a database, for example. And there's a lot of value of kind of bringing that app as close to the data as possible so that you can get the performance and latency and security concerns dealt with. Move into the welcome to the new paradigm. The new paradigm, or what we call agentic autonomous workflows. With AI, there's far more variability in the relationship between the user and the data layer and the models and the underlying systems. So for example, these multi-agent systems are going to have different kinds of natural language inputs instead of just static inputs. Again, you can think of it as choosing a drop-down menu to run your application, select some checkboxes. That's the old paradigm. Now it's, oh, just tell us what you're thinking. Well, fundamentally different kind of data input required and system management required. And there are a lot more. And then in the bottom left here, instead of just having just a structured data layer, we actually have structured and unstructured data. So let's say PDFs or images and things like that need to be broken up, chunked up, we'd say, and indexed and cataloged and embedded with vectors so that you can find them again using your LLM approach. And there's various number of models that are available on the bottom right. We're talking about needing different kinds of responses to different kinds of problems. So we have many different types of data. We have many different types of inputs, many different types of models, and we have to bundle them all together. So this new age kind of AI paradigm is fundamentally different. So you can see how these aren't just like, oh, we'll extend our database a little bit and then we'll be okay. That's not enough. Oh, we'll start to use LLMs in our new greenfield applications, but we'll still use the same background data architecture. That's not going to work either. So we have to deal with all of these components. And as even when you do get the infrastructure correct, or the architecture, I should say, correct, you still have these challenges that are just inherent to AI applications themselves. So we talked about compute and storage and stuff. That's like pervasive problems that all applications deal with. These are challenges that are really, really focused on AI development. You can have a lot of different data technologies kind of bundled together, but what you really need is a single unified data platform that already does all of the back-end plumbing as efficiently as possible between these applications. There's many integrations that help bring together data technologies, but you need the ones that are consistently bundled together in a way that makes them operationally efficient and I don't think we say it on this slide, but easy for the developer to use without having to learn 20 different technologies, even if they are integrated together. LLM hallucinations is a real thing where they doesn't come up with straight answers or sometimes correct answers. So you need to have the filters and what they call guardrails to make sure that the responses that gives back to the users aren't full of garbage, to say it politely. And there are ways to do that. Unstructured data I've talked about, we need that ability. And you need the ability to make it so that these aren't like one-off import your analyze it, chunk it up, etc., but to automate it so that you can put more data in and the systems already know what to do with it. Because your developers aren't going to want to be, you're not going to be wanting to like reprocess data over and over again, uniquely in each circumstance. We're talking about IP safety is a good thing to jump off into too if you're into more of the security side of things. But everyone can jump into ChatGPT and start talking about things, and then you realize that it's actually saving your responses now. I think maybe the general consumer will start to think a little bit more about security of their information and privacy. But obviously, in a corporate environment, this is extremely off the charts important requirement to make sure that you have AI models that can run within your own environment that you own and only you can access. Scalability, we focus on in-memory architecture so that nodes within our clusters can talk to one another from memory, from streaming from one node to another without having to really even touch the disk, and even across data centers geographically. Clusters can do this. So we need AI capability or AI application that also do the same thing. Storage just slows everything down, so we want to use the memory as efficiently as possible. There are other costs. We need to manage our costs, and one of the ways to do that is to cache. Let's say you're calling out to an external LLM that you pay for access to. You want to save the answers you get and cache them in your database, so when your users ask the same question, it doesn't have to go out and ask a third party. You can ask your system instead. Again, agentic memory and agent drifting, these are all bigger issues that are still slowly coming out of the back shadows for people to figure out how to manage. This is just a diagram to show our product called Capella, and specifically what we're calling AI services in the center piece, the kind of salmon colored boxes in the middle. But this can be anything, okay? So don't see this as just a Couchbase thing, but you should be looking for these same features in whatever platform you're building on top of. So let's just start at the top left. You have user interaction with an application. The application does something, gives it back to the user facing application. And then on the left, we've got the structured and unstructured data coming in. We've got AI integrations on the right-hand side with stuff going in and out, talking to LLMs, finding stuff outside of our system. But what we've done is built straight into the data platform itself the ability to find agents that meet your needs. This is our agent catalog capability. We have model services, so you can find and use the approved enterprise models. And then we also have the ability to put models into the system itself and access them from a variety of different interfaces. But we've simplified it as much as possible, building specifically on top of this NVIDIA NIM, but also just giving you the ability to add custom LLMs. The vectorization service, I'll show you examples of all of these in a minute, but the ability to bring in unstructured data and vectorize it automatically and pre-process it automatically are really going to be game changers in the future. And then being able to analyze that data, the data intelligence layer on the top is really important. So these are all like components of an AI data platform. And then at the very bottom here, or in the bottom of the diagram, the transactional, analytical, and vector data and machine learning features are all incredibly important. So if you did not have those, then you'd be going out again and finding solutions to bundle together to build in the transactional analytical capabilities into the system. All of the stuff we built is on top of that foundation already. So the AI architecture benefits greatly from already having a sophisticated backend that already knows how to analyze, send data, build SQL queries, etc. And if your platform can't do all that, you're going to be bundling things together again. So I wanted to walk through the complexities of a typical RAG application. You can look up that retrieval augmented generation, RAG applications of what they're for. But this is just to show you that these different stages of application development, or these different stages of a RAG application and how it works, are need to be dealt with by having certain services in your system to deal with each of them, if that makes sense. You'll see as we go along. The timeline along the top kind of aligns with the services and things that are happening below. So we need to be able to ingest data. So in this case from AWS, we pull in some PDF. We have a pre-processing service called the unstructured data service that processes that, pulls it into pieces, and spits JSON data out the other side. Then we have a vectorization service that takes that JSON data, creates vector embeddings using, say, OpenAI models, or using NVIDIA model, our model service. Our model service is a whole nother component to get the embedding models from there, and then stores those vectors that are created through the embedding process in the database. All right, so that's kind of the input side. Then when you get into the development as a developer, and you start to want to retrieve information and then generate kind of conversations around that data or natural language queries of that data, you need to do a vector search back to the database. And then you need to access your compatible APIs so that you can then interact with the LLMs the way you want. So you're pulling your own custom data out of the database. You're finding matches to, say, a natural language query or a question or input, and then you're building that knowledge up using LLMs, for example. And then you're ready, and then your application is available. And at this point, you can pull in LangChain or Llama and other frameworks to help you build that application. But if you don't have any of this back-end stuff, you're doing all of these other steps manually before you can even build an application. And then if you think of it in like an enterprise scenario, where you want people to be doing certain kinds of analysis or run certain functions on your data in your applications, or you want your developers to have access to a common set of agents. That's what these AI functions and agent catalog are for. You're going to, as you build up different ways of handling data and you build up different types of agents, you're going to need to keep track of them and make them available to your developers. And so that's built into our system. So our system aside, these are the kinds of components you're going to need to get to this final stage where you can then say, here's how our enterprise runs and creates AI applications. If you haven't nailed down what your requirements are or what your solution components are before that, you're going to have to reverse engineer it later on when you've decided which model, service, etc. works best for you. But you will need to solve each and every one of these with or without our Capella product. Okay, this is just tongue-in-cheek, but really, what does it look like? Sometimes we don't step back and go, what would it look like if we didn't do anything? Or if we just went with the status quo and kept chasing rainbows and trying the latest gadgets out and seeing where it ends? Or I'm sure if we just get this latest new LLM in or this latest new integration, we'll be laughing, right? Instead of sitting back and making a plan and really logically thinking through it. Of course, you're going to do experimentation and testing, but you need to know that at the end of the day, you need an architecture, not just little one-off sample applications, right? So here's the scenario of what went wrong. The system's just garbage and doesn't work, and the application's failed, and we put 2 years of effort into this AI initiative, and we haven't got anything out of it. Not Not much different story, I should say, than a lot of companies that go through digital reformation activities in their workplace. They can spend years and not come out the other end with a usable solution. So we don't want anyone to have to suffer through that. But what went wrong? Well, it was unscalable. You might have the best application in the world, but if it can't grow to the kind of desired user base, it's irrelevant, right? Same with data bottlenecks. If it can't grow and handle information in a real-time fashion, who cares? Unless it's some kind of reporting system that can run slow. I don't know. Integration, learning many tools and APIs makes it exponentially harder to find and fix issues. So therefore, you're chasing bugs in third-party packages on GitHub instead of just using very solid integrated components that built by people who've been building them for a decade. And similarly, the technical debt side, unpredictable experimental coding without a solid backend just leaves you chasing ghosts. So you don't want those kinds of nightmares and spiraling development costs. Again, it's the crash test dummy just going straight into the wall because they didn't know any better. And then what would be the impact, say, to your business? I just made up a few items here. You can't meet your SLAs, so you're going to lose some revenue. Your reputation is going to be trash. People are going to go to somebody else that actually handled it professionally. Your developers will be like, great, the application I spent 2 years on got thrown in the trash because a better architecture came out. And hopefully your takeaway is just that a poorly planned architecture is always a ticking time bomb, and times 1,000 for AI. It's just the way it is. So I encourage you to prioritize scalable systems, seamless integrations between parts of the components that you need, and well-integrated solutions instead of just kind of wired together behind the scenes solutions. Why consider Couchbase to help you solve this? Just got a couple slides left just to give you an overview of the company and how it applies to this scenario. I've already shown you our AI services modules, but overall with Couchbase Capella and Couchbase Enterprise, which I'll talk about in one sec, we've had really that graphic in the bottom right is the main point here. By consolidating and replacing multiple databases, our customers are able to reduce their infrastructure load, whether it's number of servers, costs of services, amount of CPU that they're paying for, etc., and bundle it all not only into a single an all-in-one architecture, but in a smaller all-in-one architecture. So if you think of it like a cluster with multiple nodes, they're using less nodes when they move to Couchbase. Go and see on our website, we have performance benchmark report that you can get. And it compares, say, in this case, I'm just looking at the logos on this one, MongoDB, Cassandra against Couchbase. And you'll see we perform as well, or we perform better in terms of operations per second with fewer nodes. So the result ends up being that more than half of our customers have reduced their total cost of ownership by 50%. So that's pretty phenomenal. And just to give you an idea, our platform capabilities are these orange columns here, and features in these orange columns. These are real customers who've written real applications. This is a selection of a variety of applications that have been developed across different verticals, and the different capabilities that we have built into our platform. I've really focused on the AI side of things because it's the newest thing, but all of these capabilities are come built in. As opposed to having to go and bundle together other capabilities on the far right here to get a piece of this and a piece of that and a piece of this. Instead, they're like subcomponents within our data platform. And this is kind of my final information slide. but this is how we view the world. You need to have, from the bottom up, development tools and SDKs that are, help you build fast on top of, industry standards like SQL. Well, we have SQL++, which is SQL plus the ability to manipulate JSON data, so you can like unnest arrays of information, but still do window functions and things like that. We build on top of that. We have a lot of different ways of deploying Couchbase. You can deploy it on premises. We have a mobile synchronization capability. We have a DBaaS offering called Capella. You can go run it if you're into Kubernetes. You can go and deploy it on your own systems, your own cloud resources with that. But geographically distributed, highly available has been our mantra from day one. I think you'll be very impressed if you see the abilities for cross-cluster communication and synchronization, even around the world. And like I said before, in memory is our kind of go-to as well. So in memory and highly available were the watchwords of the day when the company started. And then we talk about multi-purpose access services. So you put the data in once, whether it's a tabular type data or just JSON data, you put it in, and you can get you can run SQL queries against it. You can pull it out into as a document that you just send as a, say, a profile document to your mobile device or for your mobile app, or you're putting in vector indexes and doing searches and queries with natural language, or doing more complex analytics. It's really meant to be kind of a one-stop shop with multi-purpose access made from the start. So we've been around since 2011. We're traded on NASDAQ, and we've got a lot of Fortune 100 companies going on, and we've got lots of partnerships. So I encourage you to check us out. Here are the links. We've got a couple on this slide, and then one more slide. If you want to capture these or grab them in the docs that are available for download. The Couchbase Capella free tier, I want to say before we take questions, it's not just like a free trial, and there's no credit card required. It's actually a free access to a small cluster, a single node cluster in our DBaaS. So you can actually build against that, and it'll perform great. It'll perform fine for you. And then when you're ready, you'll have everything ready to go and scale up and have multi-node architecture geographically distributed around the world, et cetera, et cetera. So try the free tier, and it's free to use, free in perpetuity. As long as you use it, it'll be ready for you to use it. It'll go into hibernation if you don't use it, but check it out. And then AI services, those modules I was talking about are available through a private preview program. So you have to sign up, kind of get approved for that. I can't tell you how hard that is or anything. I'm not sure to get approved for that, but we've got a lot of people in there. And then I think this is the survey Suzanne was talking about, getting you to fill in a little more information. So we'd love to hear from you. Maybe just take a minute to pull that link up if you can, and then I'll go back. And Suzanne, is there anything you wanted to add in terms of survey responses and things like that? Okay, well, give her a minute to jump up, unmute here.
Right. No, nothing to add. Like I said, just check out the docs section. There was a question about getting this presentation. You will receive an email tomorrow with a link to the on-demand, or you can go in tomorrow with the same link that you used to log in here and view this presentation again if you'd like to. And in the docs section, Tyler just kind of wrapped it up here. This survey is really helpful to us, 1 to 2 minutes about your database priorities. And there's some other helpful links, including a link to the presentation that Tyler shared today as well. So yeah.
So if people want to watch a replay of it, it's the same like login, same access, exactly the same as logging
same
in.
thing. It just takes about 24 hours to process, but it should be available tomorrow.
So I'm just looking through the Q&A or the chat, I should say. I don't think it's Q&A is now, I think. Go Oilers. Yeah, see, I can't say go Oilers because I'm actually in between Calgary and Edmonton, so I don't know. I just have to I can't choose a team, unfortunately. Slides. was the scale of this 50% cost savings, for example, how many transactions? Yeah, you can go and look at our benchmark. You got to look at our benchmark data because it makes it much more clear where TCO ends up getting addressed. So I'm looking at Travis's question in the chat that's asking for more information about the cost savings. Some cases that you can run higher workload on fewer nodes. That's a big one for us. And then our competitors, for example. But also just the fact that you've got one system that can run your transactional info, and then also your like full text search capability or geospatial queries or your vector queries and your AI systems. So regardless of AI, we'll talk about it for a minute, it's a clustered Couchbase is a clustered environment. So you add nodes to it that can be dedicated to one type of service. So if you want to have super fast querying and indexing, you can have multiple nodes that just do the indexing and query handling, while you have other nodes that are just handling all the data management and ingest and things like that. Or you can say, I want 5 nodes that all do everything and spread the workload of everything across 5 nodes. Different scenarios require different architectures and different topologies. So a lot of companies, though, you can think of it as them collapsing this complex topology into a more simpler topology and getting the benefits of a clustered and highly available environment. So whereas in other systems, those would all be like add-ons or modules that just expand the costs and the complexity and the resource requirements. So but yeah, go and check it out. I'm not sure if we have benchmark reports on Cosmos DB or Azure at this point, but reach out to us and we can get more information there for sure. So Jeff's saying in the chat here, for Azure, check out the company BroadJump. That's a case study on our website. Depending on what vertical you're involved in, you'll find a case study on our website for sure, and you'll hear about how they're using Couchbase to really collapse that complexity.
There's also
great. Thanks for jumping in there, Jeff. It's great.
There's also another great resource. We're also featured on BenchAnt's DBAS Navigator, and that's also a third-party, independent benchmark that runs, and it also shows Couchbase versus some of our competitors. I can't speak to who else is on there, but it's also a really nice resource if you want another third-party kind of validation for Couchbase. So check that out.
That's great. Thanks for those questions. Yeah, lots of resources. I think maybe that's a good place to end it, and appreciate everybody sticking around to the end.
Yeah, thanks everybody for coming, and please do check out the docs section, and we hope to see and hear from you in July when we're going to talk more about enterprise AI agents. So hope to see you there. Take care. Have a great day.
Great. Bye-bye.